Good morning, everyone. So today we are going to talk about WebAuthn. Who has heard about WebAuthn? At least from the topic, you all should have already heard about WebAuthn. But let's take a step back and understand why we need to change the way we authenticate on the web. So, why do we all want to get rid of passwords? Do you know that in 2018, so last year, the most common password was 123456? And do you know what was the most common password in 2017? It was 12345, because most of the websites increased their minimum number of characters to 6. So basically, we are not getting anywhere. And to give you another idea, the second most common password was password. Okay. So we are all very innovative when it comes to creating new passwords. And do you know that the success rate for phishing scams in 2015, as measured by McAfee, was 97%? And that 76% of all vulnerabilities were due to weak or stolen passwords? So this is why we need to change. We need to get rid of passwords so that we are going to find out new problems, for sure, but at least we can solve the current ones. So let's look on how web authentication works on most websites today. So you have a website with a username and password field. You insert the credentials and you send them to a server. It can be a secure connection, but nevertheless, you are sending your credentials elsewhere. We all have received an email like this before. Someone sent us an email from a platform where we have an account, and they start asking things from us. So imagine that we do such an attack on a website that works like I showed in the previous slide. We click on the email, we go to a URL, and I don't know if you can notice, but this one is not the real URL. It's missing a letter. But it's barely imperceivable. And you insert your password, your username, and it basically redirects you to the real one. And you don't even notice that you put the wrong, or the password in the wrong website. And this also works like this for OTP. So when we have a new, or we receive an SMS or generate a code, we are basically streamlining the code through the malicious website. So the website in the middle saves our password, our code, and can then access our information whenever it pleases. And if you think that, well, but this doesn't happen to us, the truth is it happens to the best of us. This is the report from Citrix, for instance, where later last year they had unauthorized access to their system, and from the FBI investigation they concluded that it was most likely due to a stolen password on a phishing scam. So indeed, the problem exists. It's there. It's happening everywhere. Even today in the morning, I searched in Google for news about data breach, and you see news from today, yesterday, and the day before, and all the days you want, you see a new news about data breach. So the problem is there, and we need to fix it. And what have we done in the meantime to fix it? We have came up with multi-factor authentication. So if someone stole our password, we have a second kind of password. We have seen it in SMS. Most likely you received an email from your bank in the last weeks saying that now you also need to receive an SMS with a code. But SMSs and OTP and security questions poses several problems. The first one is they are not secure to phishing. And at the same time, they are, well, not so easy to use. So we need to, whenever we authenticate to a website, we need to have our mobile phone to get SMS or to get a code from an authenticator application. So it's something else that we need to have and we need to do in order to use it. So that's why most don't use second factor authentication. It's not that they don't understand the risks they have, it's just that they don't care. And the thing is, we are living with it every day. So can we do better? How do we improve this? Now, and this is already has a couple of years, several companies introduced U2F, Universal Second Factor. And this is basically something that you put on top of your password, but doesn't rely on a code, on an OTP code. It relies on asymmetric encryption. And with this, we indeed can bypass the risks of phishing, while we still have problems with usability, because this still is a second factor. How this works, so the device we have for this universal second factor authentication creates a new pair of keys, a public and a private key. And when the server asks the device to sign in, the device has its private key that is specific for that origin and signs the content to the server. And through this, it's a complex exchange, but putting it in simple terms, we basically guarantee that we have something that no one else has and that identifies us. And this brings the possibility of, with one device, having many services. A couple of years back, Google was using already OTP, and they have an OTP key for their web server access. So it's one of those keys that has LCD in it with the numbers, with random numbers appearing every 30 seconds or so. With those keys, you need one key per service. With this introduction of U2F, with one key, you can have unlimited number of services. So how this works? So we go to the authentication of our website. We authenticate using our password, but we also use a security key. And this basically, and the important thing is, this receives from the browser the origin. So this guarantees that we are entering on the same website that we were the original one. So if we suffer a phishing attack, the key will generate a different token because it has a different origin. So it will have a different pair, private and public keys. So the encryption of it will be different, and the password will be refused at the original website that we want to access. So we'll be immediately alerted that we have introduced our password in the wrong website. And how does it work? I told you that it has unlimited number of services that you can have on your key. So it cannot have storage limitations, because even if the storage is large enough, eventually we would end up with a limit. So I'm going to show you how Ubiquo solved this problem. Ubiquo is a company that provides these security keys. And basically, when we have a web service and a web browser, and one of these security keys, what happens is the web service sends an app ID, and the app ID is relayed from the web browser to the security key. From this, we, using a device secret that is there from production, that is imprinted into the security key, we generate, using an HMAC algorithm, we generate a pair of private and public keys. So when we receive that app ID, the next time, we are able to generate exactly the same pair of private and public keys. And we take this, and with the app ID, we send two things to the web server. Basically, the nonce and the MAC of the key and the public key. These nonce and MAC are combined into one here. And we don't see the secret because it's generated with the nonce altogether, and the public key is sent so that the web server is able to open the information. Sorry, it's able to close the information, to encrypt the information with the public key we have. So I promised you that passwords were going to disappear, but all we have seen until now requires passwords. So I have not fulfilled my promise with you yet today. But let's see how this will help us end the passwords. So basically, these security keys, these U2F, they make passwords safer, because the second factor can be something that is not able to be phished by someone else. But what about user verification? Those keys from Ubiquo, they require you to touch a button on the key to have a presence of the user, but they don't require the key to know the user. Someone can be touching the key. So if I lose my key, someone will be able to enter in the website if I use it alone. So we need to think about user verification. And thinking about user verification, we want to go and remove the passwords altogether. And that's where WebAuthn and FIDO2 appear. So FIDO2, FIDO Alliance, stands for Fast ID Online. It's a consortium of corporations, and it's a non-profit organization to improve authentication online. And they basically developed two protocols. One is called CTAP. CTAP is what allows the device that we have, like our laptop, to connect to our security key or to our authenticator device, let's say a fingerprint scan. And WebAuthn, that is the protocol that is established between the browser and the web server. And when we combine these two protocols, we have FIDO2. And this will allow us to have user authentication without passwords. WebAuthn is currently a standard for W3C, and CTAP is also implemented on all major operating systems. So today it's fully ready to use. All major browsers support this, and all major operating systems support this. So let's quickly review how we register and how we authenticate using WebAuthn. So say hi to our model that will help us showcase our scenario. And she wants to sign in into critical manufacturing MES, and she starts with their mobile phone. So she opens their mobile phone, and for the first time, she needs to register. So she clicks on register, and the mobile phone, because it has a fingerprint reader, it will ask her if she wants to enable fingerprint reading. And basically, she's automatically registered, and the fingerprint is not actually stored in the web server. That information never leaves the device. What we store is the public key of that authenticator. And this is one of the main aspects why this technology also it's compliant with GDPR and all safety regulations, because actually biometric information never leaves the authenticator device. What we store is that key handle and the public key that I've shown you before. Well, when she comes back to log in, she clicks on sign in. It will ask her for her fingerprint, and it's basically it. Well, if she wants to do this on her desktop, she can click on sign in. She will be prompted to enable also a scan, but because the device is not registered yet, remember, we don't store fingerprint information. What we store is information about the authenticator device. We need to prompt her information on other device if she doesn't have any other means of authentication. And what I'm showing you now, this pairing between your phone and the mobile browser, is being developed by Google. It's already available on the Canary version of Google Chrome. And what happens is, using a Bluetooth connection between the laptop and the mobile phone, the two devices, so without internet connection, the two devices are paired. And when I prompt something on the website, the mobile device will be notified and will ask if I want to authenticate my user. So CTAP allows both on-platform authenticators and external authenticators using NFC and Bluetooth or USB, for instance. And now I'm already 2 minutes past my time, but if the organization allows me, I want to show you a demo on how this works on a laptop. So I go to my website and I want to register. So I enter my username, and let's give a name for this authenticator then that I'm going to be using. And I click on register. And because my device, my laptop, has a fingerprint scanner, it already detected the fingerprint scanner and asked me if I want to scan my finger. So I will do that. And that's it. I've registered. And what is stored on my web server is this key that basically it's the identifier of my device. So if I log out, and I want to sign in, it will ask me for my fingerprint, and that's it. So basically, we can indeed achieve passwordless authentication. And now we have a standard on how to do this. We have seen this on mobile phones with native applications, but now we can do this on the web, on the browser, on any device. And basically, it works. So thank you very much for your attention. I don't know if you have any questions.
Sorry. It always requires a fingerprint to start the process?
No. It works with any FIDO certified device. It can be a fingerprint scanner, it's the most common currently, but it can be an iris scanner, or it can be even a USB key, if it has a PIN pad, for instance. So basically, any kind of authenticator that is certified by FIDO.